Hello, my name is Keeleen Fredrickson, and I'll be presenting on the effects of climate change on sea turtle hatching. So this is just a brief outline of my presentation. I have my introduction where I go over climate change, greenhouse gases, and ocean warming, my background where I will discuss sea turtles and temperature-dependent sex determination, my methods and results where I discuss 2 experiments, and then briefly my conclusion. So climate change is considered to be long-term changes in average climate variables such as global heat temperatures, and this occurs beyond normal variation for an extended period of time. And climate change due to unbalanced radiative heating and cooling, so the Earth is not cooling as much as it is absorbing and heating. And this is due to an increased amount of greenhouse gases in the atmosphere. The major greenhouse gases are water vapor, carbon dioxide, methane, nitrous oxide, ozone, chlorofluorocarbons, and sulfate aerosols. So greenhouse gases will naturally heat the atmosphere, and they're incredibly important for maintaining life on Earth. But as we see a lot more greenhouse gases, we see a lot more absorption of incoming UV and absorption of outgoing infrared radiation, which is a major part of the greenhouse effect, is the absorption of outgoing infrared radiation. And we see a lot of increased greenhouse gases in the atmosphere, specifically carbon dioxide, due to anthropogenic processes such as transportation or fossil fuel burning. Since 1901, the planet's surface has risen nearly 1 degree Celsius due to the increased greenhouse gases in the atmosphere. And the International Panel on Climate Change has created several emission scenarios to determine how much further the Earth will change and warm, depending on carbon dioxide emissions, and here I've outlined 3. So there's the A2 scenario, where anthropogenic carbon dioxide increases through 2100, the A1B scenario, where levels remain about equal to those today, and the B1 scenario, where carbon dioxide emissions are reduced drastically through 2100. So the more greenhouse gases we have in the atmosphere, the more warming we have, and this really translates to warming of the ocean and also of the land. So the ocean accounts for 93% of Earth's heat uptake, and as the atmosphere warms, the land warms, but the ocean also warms and absorbs that heat, and then can further heat the atmosphere as well. So it's really a positive feedback loop going on with the ocean warming and the atmosphere as well as the land warming. So we see in the ocean, when we have a lot of heat, a decrease in some processes that occur, such as a decrease in thermohaline circulation, which is the circulation of ocean water based on salinity and heat. So this decrease in thermohaline circulation has led to even further warming because it cannot create equilibrium very well. But we also see rising sea levels with ocean warming. Initially, this is due to thermal expansion because water naturally expands when it warms, but really big contributors are loss of sea ice and melting of land-based glaciers. So when the ocean warms, the land-based glaciers will then melt into the ocean, causing rising sea levels. And sea levels are expected to rise 38 centimeters to 59 centimeters by 2100. So for sea turtles are incredibly dependent on incubation temperatures for their sex determination. So fertilized sea turtle eggs are buried in nests on beaches, really close to sea contact and obviously within the sand. And the temperature in which they incubate and they develop determines which sex they are. So for sea turtles, ZZ is males and ZW is females. For comparison, humans, XX is females and XY is males. And for humans and a lot of other mammals, we have genetic determination of our sex. So your mother donates the X and your father either donates the X or the Y, but that is not how it works in sea turtles. So for example, incubation temperatures of 26 to 28 degrees Celsius results in mostly male sea turtles. Incubation temperatures of 28 to 30 degrees Celsius results in an even distribution of males and females, and 30 to 34 degrees Celsius results in mostly females. So more rising land and sea temperatures and sea levels can affect sea turtle hatching and their success as well, beyond just skewed sex ratios. So this is the first case study that I will be outlining from Wood in 2013. So they studied sex ratios and mortality of loggerhead turtles at the Monrepos rookery in Australia. A rookery is just where the eggs are buried and then hatch. And they studied 28 nests in total. So what they did is they gave them artificial shade so they could vary the amount of sunlight each nest received. So nests received from 9 hours to 0.5 hours a day of sunlight. So it was 9 hours, 4 hours, 1.5 hours, and 0.5 hours a day. And the other times of the day they were shaded. And throughout this experiment, they measured sand temperatures constantly so that they could determine how sunlight, sand temperatures, mortality, success, and sex are all correlated and related. So after they hatched, they weighed the hatchlings, they observed them on their motility and several other things, and they also had them display their writing ability, so they flipped them on their back to see if they could write themselves very well. And they obviously determined that the nests with the most sunlight had higher mean temperatures. So obviously the nests with the most sun were the hottest, but sand temperature is not equal to nest temperature. A high sand temperature, such as 28 degrees Celsius, results in a nest temperature higher than that, so maybe 29 degrees Celsius nest temperature. So high sand temperatures do equal high nest temperatures, but the nest temperatures are typically always higher than the sand temperatures. And then this also has an effect on sex ratios and success. So the nests that they measured had temperatures from 29.8 degrees Celsius to 31.7 degrees Celsius. They found that the hatching success was about 83% across the nests, and this is consistent with a lot of other experiments on hatching success. The nests with the lowest temperature had the greatest emergent success, so those that incubated in the lowest temperature of 29.8 degrees, the more of them left the nest than in the higher temperatures. Now, for sex ratios, the nest with 9 hours of sunlight was 95% female. The nest with 4 hours of sunlight was 79% female. The nest with 1.5 hours of sunlight was 61% female. And the nest with 0.5 hours of sunlight was about 54.6% female, so about a 50-50 ratio. Now, Lelot et al. In 2017 really looked at how skewed sex ratios as discovered in the past experiment by Wood, how this could be possibly beneficial to current populations of sea turtles. So they studied loggerhead turtles in Cape Verde over 6 breeding seasons in a total of 3,687 nests. So they have a large variety of data. And so they obtained sand and air temperatures during the breeding season, and they looked for hatching success, which they've defined as the number of turtles that actually hatch from their eggs, and emergent success, which was defined as the number of turtles that actually are able to leave the nest and start moving towards the ocean. But a major thing that they did is they utilized IPCC emission scenarios to determine future effects to see some implications on sea turtle hatching in the future. So what they found was that current incubation temperatures of 28.5 degrees Celsius to 32.2 degrees Celsius results in an emergent success of about 82%, which is really similar to what Wood found in 2013. But they've also predicted that nests will increase by 29.1% by 2100. And this is because we have a lot of extra females due to high incubation temperatures that result in extra females. Male turtles are able to mate multiple females, so you don't need like a 1-to-1 ratio in order to have a lot of hatchlings. So with a lot of extra females, we have more females getting fertilized, and thus more nest numbers allowed. But they found that as temperatures are rising, we may reach lethal temperatures, causing nest numbers to decrease drastically. And they use the emission scenarios A2, A1b, and B1 to display implications from future climate change and emissions on sea turtles. So this displays how hatchling survival is greatly related to incubation temperature. So the incubation temperatures that they discovered are the current incubation temperatures that resulted in a hatchling survival of 82%. Are about here up to about 32 degrees Celsius, but we see as it drops to 34 degrees Celsius, hatchling survival declines drastically. And this is because 34 degrees Celsius is considered a lethal temperature. So as lethal temperatures increase, the number of nests will decrease because we're losing potential breeding animals and they are just not surviving to be able to hatch. A major thing that they also did was that they utilized IPCC emission scenarios to determine how air temperature will be affected, emergent success, and then relative nest numbers will be affected. So using the A2 scenario, this red line right here at the top, where emissions continue to increase through 2100, we see that air temperature increases drastically to 29.5 degrees Celsius by 2100, and nest numbers, while they increase until 2100, which was predicted, they drop drastically by 2150. And emergent success as well drops drastically by 2100 to about 50% emerging success. So this is a 30% drop. In the A1B scenario, which is about the intermediate, where emissions stay the same as they are today, air temperature increases to 28.8 degrees Celsius. Nest numbers continue to increase till 2100, but they decrease just intermediately by about 2150. But they also find that the emergent success decreased intermediately as well until about 70% emerging success, so just about a 10% drop. Now the B2 scenario is potentially the best for these sea turtles. So we see an air temperature that mildly increases to 27.5 degrees Celsius. We see that nest numbers continue to increase, and then they eventually just plateau. So they do not increase under this scenario by 2150. So they plateau. And emergent success will still stay steady at about 82 or 83% emergent success, which is very beneficial for these turtles. Now, just an evaluation of these case studies, Wood et al. They had a relatively small sample size, but they had well-defined non-subjective measures. So the riding ability and the emerging success, these were very beneficial to evaluating how temperatures affect these, and this can really be amplified for larger scenarios. They also found that artificial shade can prove helpful to protecting sea turtles. So they've used this idea as a mitigation effort to protect turtles from rising atmospheric and land and sea temperatures by providing artificial shade to really control the sex determination here. Now, Lolo in 2017, they had a very large sample size, which was very helpful, and their IPCC scenarios are really easy to evaluate and see how sea turtles will be affected. However, obviously these predictions may not be completely accurate, but they are very helpful in determining this vulnerability. One downside was that they did have to use some estimations, such as the nest temperatures for the not hatching seasons. And they only measured incubation temperatures for 800 nests, while they determined hatching success for over 3,000 nests, so they limited their potential results here, but they both really display potential vulnerability to climate change very well. So in conclusion, turtles depend on narrow temperature levels to determine their sex. So the future for turtles right now is really female dominated, and because of this, we'll see an increase in nest numbers until about 2100, until sand temperature and nest temperatures reach about 34 degrees Celsius, and this will result in a drastic decrease in nest numbers and a drastic decrease in hatchling survival. Now, many animals are dependent on temperature for sex and success. A lot of reptiles are. So we must decrease our greenhouse gas emissions to protect these vulnerable species across the globe from further loss and eventual extinction. Now, this is just my works cited.